standing on the threshold of a fundamental transformation. The technological trends of 2025-2026 reveal to us not merely a picture of evolutionary changes, but a revolutionary transformation of the very nature of professional activity. By analyzing the learning activity of users across diverse platforms, we see patterns that compel us to reconsider our understanding of the future of work. Our analysis is not merely a record of statistics. It is an analytical interpretation of trends and a forward-looking projection, enabling us to uncover hidden connections and patterns shaping the evolution of the professional landscape. Artificial intelligence has shown the highest growth rates. Machine learning increased by 9.2%, artificial intelligence by 190%, natural language processing by 39%, generative AI by 289%, and prompt engineering by an astounding 456%. But the most interesting thing is not in these numbers. What is fascinating is that interest in GPT dropped by 13%, while overall interest in AI grew. This indicates the cognitive maturity of the technological community. People are ceasing to be fascinated by specific brands and are beginning to understand the fundamental principles. Philosophically, this resembles the transition from alchemy to chemistry. Alchemists sought the philosopher's stone. Modern specialists seek universal principles for working with any language model. Platform users have realized that what matters is not studying GPT, Claude, or Gemini, but acquiring the fundamental knowledge needed to work with any model. Aristotle distinguished between episteme, theoretical knowledge, and techne, practical art. The modern development of AI demonstrates a return to this dichotomy. Mastery of specific tools, techne, is becoming less important than understanding the principles of their functioning, episteme. When a programmer transitions from writing code to designing system architecture, they are moving from techne to episteme, from craft to science. A revolutionary trend is the agent paradigm. LangChain has reached a level of usage comparable to PyTorch, and RAG has reached the level of Keras, even though a year ago these technologies practically did not exist in educational content. Agents are not just the next wave of AI, they are a fundamentally new form of computation, where programs plan and execute multi-step actions autonomously. Paradoxically, interest in learning programming languages is declining. Python dropped by 53%, Java by 13%, C++ by 9%. The exception was Rust, which grew by 9.6%. This does not mean the death of programming. It means the transformation of the very nature of development. When AI helps to write code, programmers can focus on architectural solutions and solving complex problems. Martin Heidegger wrote about readiness to hand, the state when a tool becomes an extension of our body and disappears from consciousness during use. Programmers who rely on AI to generate code risk losing this state of flow with programming languages. Rust is growing perhaps because its philosophy of memory ownership requires deep understanding that cannot simply be delegated to a machine. Security has finally gained the status of a strategic priority. Security governance became the most used skill in the field of security, growing by 7.3%, surpassing network security. Governance, risk, and compliance grew by 44%. This signals a shift from reactive firefighting to a proactive systemic approach. Company executives are tired of appearing in the news due to data leaks. Cloud technologies have reached saturation. The use of content about major cloud providers declined across all categories, except for Google Cloud certifications, growth of 22%. This does not mean repatriation. It means that cloud migration is complete. Now companies need to learn how to manage their cloud investments effectively. Plato and Phaedrus condemned writing, fearing it would weaken human memory. Today, we observe similar concerns regarding cloud technologies. By delegating infrastructure management to providers, are we not losing fundamental skills? The saturation of the cloud market shows that the technological community has found a balance between convenience and control. Platform engineering is becoming the new paradigm of DevOps. Kubernetes dropped by 20%, DevOps by 23%, but this does not mean the departure from these technologies. It means abstraction of complexity at the platform level, where a small team of platform engineers can serve the needs of many development teams. Professional development is gaining critical importance. Engineering leadership grew by 9.6%, personal productivity by 21.5%. In a world where technical skills are rapidly automated by AI, human skills of communication and leadership are becoming irreplaceable. Sociologists distinguish between hard skills and soft skills, but this dichotomy is becoming outdated. Aristotle spoke of phronesis, practical wisdom, the ability to make the right decisions in a specific situation. Engineering leadership is the modern embodiment of phronesis, a synthesis of technical understanding and human wisdom, the ability to see technical solutions in the context of human needs and organizational goals. But the development of leadership skills is only one side of the transformation. In parallel, a revolution is taking place in the very nature of software systems, where static algorithms give way to dynamic agents. These trends form only the surface layer of deeper transformations. To fully understand the future of technology, it is necessary to delve into the mechanisms that drive these changes from within and understand how to practically adapt to the new reality. Agent architecture represents a fundamental shift from deterministic programming to emergent behavior. Traditional programs execute strictly defined sequences of commands, while agents act as autonomous entities that analyze context, plan actions, and adapt to unpredictable situations. It is like the difference between following a recipe and the improvisation of an experienced chef. RAG technology allows agents to access a company's private knowledge bases in real time, creating responses based on current data rather than solely on what the model memorized during training. Leibniz imagined the universe as a system of interacting monads, simple substances that have no windows but coexist harmoniously thanks to pre-established harmony. AI agents resemble this metaphysical model. Each agent is autonomous, but their interaction creates the emergent behavior of the system. The difference is that instead of divine harmony, we have coordination algorithms. Practically, this means that instead of creating separate programs for each task, you can build an ecosystem of interacting agents. One agent analyzes customer input data, another generates personalized offers, and a third checks them for regulatory compliance. Each agent specializes in its own domain, but together they create a complex decision-making system. The key to successful implementation is to start with simple tasks and gradually increase complexity, allowing agents to learn from your business's real data. The transformation of the programmer's role takes place at the epistemological level. When a machine can generate code, the programmer becomes an architect of meaning. Instead of writing sorting algorithms, the modern developer designs systems of interaction, defines the boundaries of component responsibility, and ensures data integrity in complex distributed architectures. Rust is growing not because it is fashionable, but because its philosophy of memory safety resonates with new challenges, where one error in resource management can cost millions. Wittgenstein distinguished between saying and showing. Some things cannot be expressed in words. They can only be demonstrated. The architecture of software systems belongs to the sphere of showing. It embodies organizational principles that cannot always be explicitly formulated. AI can generate code, but cannot show the elegant architecture that arises from a deep understanding of the problem domain. You can adapt by focusing on understanding the principles of system design rather than memorizing syntax. Study architectural patterns, understand trade-offs between performance and reliability, and develop intuition about when a system is ready for scaling. AI will help with implementation, but cannot replace the understanding of what exactly needs to be implemented. The revolution in security comes from the realization that cybersecurity is not a technical problem, but a problem of risk management. Zero-trust architecture assumes that threats can come from anywhere, including trusted users and internal systems. This is a philosophical shift from defensive thinking to adaptive resilience. Systems must remain functional even after part of the components are compromised. Thomas Hobbes described the state of nature as a war of all against all, where life is solitary, poor, nasty, brutish, and short. Zero-trust architecture proceeds from a similar assumption about cyberspace: trust no one and nothing by default. But unlike Hobbes's Leviathan, which requires absolute power, zero trust creates a distributed system of mutual control. To implement this approach, start with an inventory of all access points to your data, including APIs, databases, and file systems. Every access must be authenticated and authorized regardless of its source. This creates additional overhead but ensures controllability at every stage. Governance becomes critically important as security policies need to be managed centrally but applied in a decentralized manner. Cloud maturity means the transition from the enthusiasm of migration to cost and performance optimization. Companies have already realized that the cloud is not a panacea, but a set of trade-offs. It offers flexibility at the expense of control, scalability at the expense of cost transparency. The constant movement of workloads between cloud and on-premises environments reflects the search for the optimal balance for each specific task. Heraclitus argued that everything flows. Change is the only constant. The constant migration of workloads between the cloud and on-premises data centers embodies this philosophy. Organizations are learning to live in a state of constant movement, optimizing application placement not as a one-time decision, but as a continuous process of adaptation. Your strategy should be based on understanding the characteristics of your workloads. Compute-intensive tasks with predictable demand may be more cost-effective on your own infrastructure. Workloads with fluctuating demand peaks are ideally suited for the cloud. Data requiring a high level of access control may remain on-premises, while data for analytics can migrate to the cloud to leverage specialized services. Platform engineering synthesizes the principles of DevOps and SRE into a new paradigm of abstraction. Instead of every development team learning all the intricacies of Kubernetes, the platform engineering team creates self-service interfaces that allow developers to deploy their applications without a deep understanding of the underlying infrastructure. This is cognitive economy on an organizational scale. Implement platform engineering gradually, starting with the most repetitive tasks. Create templates for common architectures, automate CI/CD processes, and provide tools for monitoring and logging. It is critically important to involve development teams in platform design. It should solve their real problems, not create additional abstractions for the sake of abstractions. The development of professional skills becomes a strategic investment in the age of automation. Machines can generate code, but they cannot understand business needs, manage stakeholder expectations, or resolve conflicts within teams. Engineering leadership is not just about managing people. It is about creating conditions in which technical teams can collaborate with business most effectively. Sociologists distinguish between hard skills and soft skills, but this dichotomy is becoming outdated. Aristotle spoke of phronesis, practical wisdom, the ability to make the right decisions in a specific situation. Engineering leadership is the modern embodiment of phronesis, a synthesis of technical understanding and human wisdom, the ability to see technical solutions in the context of human needs and organizational goals. Develop active listening skills, learn to translate technical concepts into simple language, and master facilitation techniques for group decision-making. Most importantly, develop systems thinking, the ability to see connections between seemingly independent components of an organization. This is something AI cannot replace, at least in the near future. The cognitive architecture of the future is based on the symbiosis of human and machine intelligence. Prompt engineering is not a temporary phenomenon, as some experts claim. It is the evolution of the human ability to formulate thoughts. When you create a prompt, you are not just giving a command to a machine, you are structuring your own thinking, detailing the context, explicitly formulating the criteria for success. This is a metacognitive process that forces us to become better thinkers. Kant emphasized that human reason is not capable of knowing everything, but only what can be comprehended within the limits of our categories. Recognizing these limits opens the path to genuine knowledge. Interaction with AI requires a similar approach, understanding the boundaries of one's own knowledge and the machine's capabilities. Prompt engineering is the art of formulating the right questions, reminiscent of the method of critical philosophy, where truth emerges through constant refinement and verification. Effective interaction with AI requires an understanding of its epistemological limitations. Language models do not know in the traditional sense. They reproduce patterns from training data. This means they can generate plausible but factually inaccurate answers. Your role is to become a curator of truth, a verifier of accuracy, an architect of context. Develop skills in critical analysis of generated content, learn to ask clarifying questions, and build systems of checks and balances. The transformation of educational processes is taking place through personalization at a level that was previously impossible. AI can analyze your learning style, identify gaps in knowledge, and generate individual learning trajectories. But this creates a new responsibility: to learn together with the machine. The traditional model of the teacher transmits knowledge to the student is being replaced by the human and AI jointly explore the subject area. Practically, this means that instead of passively consuming ready-made content, you become an active co-author of the learning process. AI generates basic material. You supplement it with your own experience, adapt it to the specifics of your context, and create connections with other areas of knowledge. Develop self-diagnosis skills. Regularly assess your knowledge, identify weaknesses, and formulate specific learning goals. The data economy is moving from the paradigm of storage to the paradigm of activation. Data lakes and data lakehouses are not just repositories of information. They are potential sources of competitive advantage. The key understanding is that the value of data lies not in its quantity, but in the ability to quickly turn it into actionable insights. ETL processes are evolving toward real-time processing, where data is analyzed and applied almost immediately after arrival. For effective data management, focus on creating a semantic layer, a unified way of describing and categorizing your data. This will allow different systems and teams to work with the same understanding of what specific metrics or attributes mean. Invest in data lineage, the ability to trace the origin of each data element from source to end use. This is critically important for regulatory compliance and building trust in analytical conclusions. Microservice architecture is experiencing a period of reflection after years of euphoria. The decline in interest in microservices does not mean their demise. It means a maturity of understanding when they are appropriate and when they create unnecessary complexity. Modular, monolithic architectures offer a compromise between deployment simplicity and structural flexibility. This is the philosophy of gradual growth in complexity, according to the real needs of the business. When designing a system architecture, start with a monolith, but structure it modularly from the very beginning. Create clear boundaries between functional areas, minimize coupling between modules, and ensure the ability to independently test components. When a particular module becomes a performance bottleneck or requires separate scaling, then separate it into its own service. This approach allows you to avoid premature optimization and focus on solving real, not hypothetical problems. The evolution of web development demonstrates the cyclicality of technological trends. The return to simplicity, represented by frameworks like HTMX, is not regression. It is a conscious rejection of complexity for the sake of complexity. Modern networks and devices are more powerful than ever in history, but the user experience is often worse than it was decades ago. This is the paradox of technological progress, where means become more important than goals. To create effective web applications, return to fundamental principles. Understanding the HTTP protocol, the semantics of HTML, and the cascading nature of CSS becomes more important than knowledge of specific frameworks. Progressive enhancement, the principle where basic functionality works even without JavaScript, is becoming relevant again. This does not mean abandoning modern tools, but using them wisely where they truly add value. Certification in the age of AI is acquiring new meaning. When machines can generate code and even pass exams, the value of certification shifts from demonstrating knowledge of facts to proving the ability to make decisions under uncertainty. This is especially relevant in the field of security, where mistakes cost reputation and financial losses. Certification becomes a way to prove that you can not only apply ready-made solutions, but also adapt them to the unique challenges of your organization. The future of skills lies at the intersection of technical expertise and human wisdom. Develop T-shaped skills, deep expertise in one area, plus broad understanding of related disciplines. This will allow you to collaborate effectively with AI, using it to expand your capabilities without losing control over strategic decisions. The most valuable specialists of the future are those who can see opportunities where others see only problems and can turn technical possibilities into business solutions. The philosophical challenge of these trends lies in the fact that we are experiencing not just a technological revolution, but a cognitive one. Machines are learning to think, and people must learn to think together with machines. This requires not only technical skills but also a deep understanding of the limits and possibilities of artificial intelligence. Descartes postulated the dualism of mind and body, but modern neuroscience shows their inseparable unity. Similarly, the dichotomy of human or machine is giving way to a new paradigm of hybrid intelligence. We are not replacing human thinking with artificial. We are creating a new form of cognitive symbiosis, where the boundaries between biological and digital mind are becoming increasingly conditional. The greatest risk is not that AI will replace humans, but that humans will stop developing, relying solely on machines. Those who use AI only as a copy and paste tool will soon become redundant. The future belongs to those who learn to collaborate with artificial intelligence to create something better than AI could create on its own.